Hello everyone, welcome to the course Data Structures. This is N. Thulasi Chitra, Associate Professor, Department of CSIT, MLR Institute of Technology. In today's session, we will be discussing about the binary tree traversals. Let us see the overview of today's session. Here we will be discussing about what is traversal, what is the definition of traversal, followed by what are different types of traversals we have. Then we will be looking into what is a binary tree traversal, right? Let us go for what is traversal is. Traversal is nothing but visiting each node exactly once in a binary tree, right? Suppose if I am going to have a tree, right? Suppose in this I am going to visit this particular node. Visiting each node, any of the node, exactly only once we need to visit that particular node. That is nothing but a traversal. And when you are going to use this traversal can be done in two ways. One is a recursive traversal and another one is iterative traversal. As you may already studied in your programming for problem solving, what is recursion and what is iteration. In recursion, we are going to call the function the number of times, or we are going to call the function by itself, is nothing but the recursion, and the iteration is nothing but where we are going to use any loop statements, like you are going to have for loop, while loop and do while loop. These are the different loop statements. When we are going to use these things in our traversal, then we are going to name it as iterative traversals. Otherwise, it is a recursive traversal. Most of our examples, we are going to solve it by using recursive traversals. Coming to different types of traversals we have. Here, totally we have 6 recursive traversals and non-recursive traversals. Non-recursive are nothing but the iterative traversals. Both the things we can apply on these traversals. In that, mainly we need to concentrate on the 6 different types of traversals that can be applied on binary trees. What are those? One is in-order traversal, other one is pre-order traversal, the other one is post-order traversal. These are the 3 traversals mainly we need to concentrate on. And opposite to that, we are going to have converse in-order traversal, converse pre-order traversal and converse post-order traversal. Okay, this how these 3 are differed from the normal one, we will see. You can see the diagrammatic representation here, where it is going to represent what is in-order, pre-order and post-order traversal. What is in-order traversal? Let us see. Suppose if you have a binary tree like this, what is an in-order traversal? How the traversing is going to be done? Here, the in-order traversal means, here we have some condition, like first we need to visit the left node, followed by root node, and then followed by right subtree. Left subtree, in that again the same condition has to be applied, then followed by the root node, and then the right subtree has to be traversed to visit the nodes, right? All the nodes has to be visited, but one condition is one node can be visited only once, exactly once, right? Now based on this condition, we are going to write how the traversing is going to be happen in the in-order traversal. First, from the root node, we are going to visit the left subtree. Yes, the left subtree node is B, that will be visited, and then we have a root node, that is A will be visited, and then followed by the right subtree. Right subtree have only one node, that is C is going to be visited. This is the condition where we are going to visit the nodes in the in-order. In the same way, we have pre-order. Pre-order means, pre means the root should come first, then followed by left and right subtrees. According to that, first the root should be visited, that's why we are going to represent A, then followed by B, that is the left subtree has to be visited, that is B, And the last one we have the right subtree. That means we are going to have like this way. We are going to visit the 3 nodes. And coming to the post order. Post order means the root should come last. And before that we need to visit the left and right child. And if you can see here from this tree, first we need to visit the left subtree. What is the left subtree? We have B, and then right subtree, that is C, and then followed by the root node, that is E. Like this way we are going to visit the nodes in the post order traversal. Now coming to the converse or opposite to the in order, pre-order and post order traversals, if you can look into this diagrammatic representation and the visited nodes. Here, first opposite to this in order traversal, first we need to visit the right subtree, then followed by the left, followed by the root node, and then we need to visit the left subtree. Just you see here, these two are going to be changed, right? The remaining root node may be the same. Root node will be the same, and left and right child is in the reverse order, right? Now you can see here, first we are going to visit the right child, then followed by the root node, and then followed by the left subtree, right? This is for the converse in order. In the same way, we are going to use it for the pre-order and post-order also. Here, the pre-order, you know that root will be the first node to be visited, and after that we are going to visit the left and right in the pre-order. Converse pre-order means reverse to that. That is first root, first right, and then left subtrees are going to be visited. Now according to that, the root will be visited first A, then right subtree and left subtree, right? And the same way, post order traversal, root should come in the last, and we are going to change the reverse order of left and right subtrees, right? First we need to visit the right subtree, then followed by the left subtree, and then we need to visit the root node. This is how where we are going to have the different traversals to be applied on binary trees. The same thing what we have applied, for that we are going to see the algorithm how we are going to traverse in a binary tree if we have more number of nodes. In the previous case we have seen only 3 nodes, but here will be the same algorithm will be applicable for left subtree as well as the right subtree, right? Let us see what is the condition here for in order traversal. In order, in means the root should come in the middle, then left and right subtrees, right? Now what is the algorithm we are going to apply? Let us see. Traverse the left subtree, right? Previously we have seen only 3 nodes. You may have like this also. You may have a chance of having a binary tree like this also, right? In this case, what we need to do? First, we need to traverse the left subtree. Complete left subtree we need to traverse. And after completing the left subtree, then we need to visit the root node, right? The same thing. Call in order traversal. Then visit the root node. That means this is going to be called recursively. Until the completion of left subtree, we are going to call them recursively. If I am going to have some other nodes, that one also we are going to take, right? We need to completely go for the left subtree and then we need to visit it, okay? And after completing the left subtree, then we need to visit the root node and then followed by the right subtree. The right subtree also we are going to call recursively. If I am going to have a tree like this, then I am going to call it recursively until the completion of right subtree. This is the process where we are going to apply in the in order traversal. In order traversal, let us see the example how we are going to solve this in order traversal. This is the tree that was given. First, we need to visit the left subtree, right? This is the left subtree where I am going to have this part. This is the left subtree. And in this, again, we need to check for B, again, we have any left subtree or not. Yes. Here we have one node, but you don't have any children for it. We have only one node. That should be visited first. B has to be visited first. Why? Because you don't have any children. Left and right is not there. Left and right children are not there. So that we are going to visit the root node. right? That's why we are going to visit the D value. And then coming back, for this is the left subtree, right? And for this is the left child already visited. Now apply this condition for the node with the left root and right? This is a root node for you don't have any left and right children, that is visited. Now for this particular left subtree, now observe the left node has to be visited. Already we have represented it. D. Sorry. Then followed by B, that is the root node to be visited. D, B. Then for this left subtree, which is the right child, we have E is there, that has to be visited. Now I have completed the complete left subtree. Now I need to visit the which node? A root node. This left subtree is completed. Now we need to visit the root node. A should be visited. And coming to the right subtree, this is my right subtree. I need to check for is there any right subtree for these nodes for F and G. I don't have. So that we need to follow the same condition for left in-order traversing for again the right subtree. Now here when I am going to see here, if I am going to apply the same condition for right subtree, you have left root and right. Which is the left one? Left node is F, right node is C, and root node is C, sorry, and right node is G, right? Like this way we need to visit in the in-order traversal. Now the same thing we have represented it in the algorithmic form, right? Just we are going to call the function of in order, we need to pass the root value. If the root is not null, if we are going to have some node or an element that was present for a root node, it will have some address. If that is not null, then we are going to repeat this process. First we are going to call the in order of root arrow left. That is nothing but we are going to completely call the left subtree. After completing that left subtree, we are going to visit the root node and we are going to print it. Then we are going to call the right subtree and we are going to completely recursively call that right subtree and we are going to follow the condition of left root and right. This is how the algorithm will work. And if you can see here, this is a shortcut representation whether we have represented the in-order traversal in a correct way or not. How we can know that, right? This is very simple. Let us see the diagrammatic representation which I have given with the binary tree. Here, suppose in shortcut you can see, keep a plane mirror horizontally at the bottom of the tree. If suppose I have placed a mirror over here and take the projection of all the nodes. I am going to take the projection of all the nodes by representing with some dotted lines, right? You consider this is the mirror where you have what is the line you are finding. This is a mirror. On that, how the projection will be represented with these dotted lines, right? According to these dotted lines, whatever you are finding, the order you write it. The order you write it. First, yeah, I am going to find D. This is my first projection. Then B, then E, then A, then F, and then C and G. Right? Like this way, if I am going to write it, from this you can able to draw in-order traversal. Okay, and where we are going to use this in-order traversal in our real-time applications. In-order traversals can be used in infix expressions of an expression tree. Suppose if you have given an expression A plus B into C, this expression can be represented in a tree format. A plus B into C. Something like this, right? You will be learning about these expression trees in terms of in the subject called compiler design. There you will be knowing in detail about this expression tree representation. Okay. Then coming to find the in-order traversal for the given tree. You can able to try these examples, right? Otherwise, I will be solving one example. Based on that, you can solve the remaining. You consider this is a mirror. You write the projection lines for this in the order, right? And you may be getting this line first, then this, then this, then this, right? Now, what is the out of the resultant in order traversal, you are going to get 5, 15, 18, 20, 25, 30, 35, 40, 45, 50 and 60. Right, this is the order where you are going to get. If you could observe in the in order traversal, all the elements are in the sorted order. If you can see here, these elements are in the sorted order. Yes, here already represented. And in a similar way, where we are going to have the other traversal is pre-order traversal, that is root left and right. In the in order, the root comes in the middle. In the pre-order, we are going to get the root at the first and then left and right childs after that. First visit the root node, then traverse the left subtree completely and traverse the right subtree completely. This is going to be done recursively. Now you see here how simply we can do this pre-order traversal. Pre-order means first we need to visit the root node. That means A has to be visited. Then followed by the left subtree has to be visited. And on that also first we need to apply the same condition, root left right. The root is B, left is this one and right is this one, D and E. Right? And after completing this, come for the right subtree and apply the same condition. First root should be visited, then left subtree has to be visited. You don't have any left subtree elements, only one element is there, F is visited and then G is visited. And where you are going to apply this pre-order traversal, again this is going to be used in expression tree, and this is used to create a copy of the tree. That means the same copy of the tree if I want to represent this, then in that case we are going to use this pre-order traversals. In a similar way, we are going to have the pre-order traversal algorithm. First, we are going to have a function called pre-order where you are going to pass the root node. And here root is not null means you are going to have a tree with some address. In the same way, we are going to visit the root node first, and pre-order and post-order traversals are going to be, or functions are going to be called recursively. And in short representation, how we are going to have this pre-order traversal. Just you start from the root node, visit all the nodes in the order of this one. If I am going to represent like this, first I am going to visit A, then B, then D, then E. Already A already visited, no need to visit again. Then F, C, G. And again you need to come to the starting position. This is a short representation where we are going to represent the pre-order traversal. And if you can see, we can able to draw a pre-order traversal for any of these examples you can solve. Yes, I am going to start from A, B, D, C, E, F, or C already visited, F, H, I and A. Right? Whether it is correct or not, just you can check. A, B, D, you have visited C, E, G, F, H, I and I. Right? You can try this example based on the same way of traversing. Right? You can check after representation of your pre-order traversal. You can check with the answer. This is the answer where you need to get it. Next. Post-order traversal, here it should follow the condition left, right and root. Here first we need to visit the traversing the left subtree first, then traverse the right subtree and visit the root node. And in the post-order traversal, as the same condition where we have left, root, right, and you can see here how we are going to do this post-order traversal. It is little bit difference with compared with the in-order and pre-order traversals. Here, observe. First, I am going to completely go for the left subtree. This is my left subtree. In this left subtree, again go to the complete left. Yes, completely left has been visited. Then From there, you visit the left subtree, that is left node has to be visited, that is D is visited. Then followed by the right subtree, that is E is visited, and then the root node has to be visited. That is D, E, B will be done. And after that, come to the right subtree. In that again check for the left subtree and right subtree if you have. Then based on that, first we need to visit the left subtree, that is F has to be visited. Then right subtree G has to be visited, and then root node has to be visited, C has to be visited, and at last you need to visit the root node, right? In this way we are going to perform a post order traversal, and this is also going to be used in postfix expression of an expression tree. Postfix expression is there. In infix, postfix and prefix expressions are there. Based on that expressions, we are going to construct these expression trees. And where you are going to use this pre-order traversal is used to delete the tree. That is, the post-order traversal is mainly used for deleting the tree. For that purpose, we are going to use this post-order traversals. This is because it deletes the children first and then it deletes the parent. When I want to completely delete the nodes in the tree, in that particular case, I can't directly delete my root node. Whatever the children that was present to it, first that has to be deleted. Then only I can delete the complete tree. Okay. Now this is the post order traversal where you can apply. This is a function, post order function, where you are going to call and pass the root value. If the root is not null, in that particular case, we are going to call first post order left subtree and post order right subtree. Then we are going to print the root. And this is the short representation. Pluck all the leftmost leaf nodes one by one, right? That means the children has to be removed and then the parent has to be removed. First, which is the children here? D has to be removed. D is going to be visited. E is removed. E is going to be visited. After removing these two nodes, we are left with only one children, that is B, that has to be visited. Okay. And after completing that, I can't remove A directly. That's why we need to go for this part, right subpart. Right subtree, right? In that F has to be deleted, then G has to be deleted, then only we can remove C. Right? After deleting all these, now we are going to delete E. That means in the same way we are going to, how we are removing the nodes from the tree, in the same order we are going to perform the traversing in the post order traversal. Now you can able to see the same diagrammatic representation, and first we'll represent it, what you are going to get it based on the pre-order, and you can verify it, right? For this, we are going to go for the complete left subtree. What you are going to get, you don't have this left part and you have the right part. That means D has to be visited. After removing D, we are going to visit B. After removing B, completely come to this part. Here you have G. G has to be removed first. Then after removing G, you are going to remove E. E has to be removed. Next, coming to this part, I can't directly remove C. Why? Because I am having the right subtree. Then I have to remove H, then I, then F, then C, then E. This is the post order traversal where we are going to get it. Let us check whether we have represented the same or not. As D, B, G, E, H, I, F, C, A. This was the post order traversal, and you can try this example on your own in the same way. Apply the algorithm or apply this shortcut representation and you can represent the post order traversal. Yes, up to this we have completed the binary tree traversals. Let us see what is the summary of this today's session. Here we have discussed about the traversals. Then we have seen types of traversals, what we have. That is in order, pre-order, post-order traversals we have discussed, and then we have discussed about binary tree traversals. Under binary tree traversals also we come across in order, pre-order and post-order traversals, and how we are going to traverse through the nodes and how we are going to represent them easily in shortcut ways we have seen, and what are the applications also we have discussed. I hope you understand this concept. Thank you.